There are 6 basic laws of indices which are very important for the exercise. This whole exercise depends on the application of that formula. So I suggest my students to keep all that basic laws of indices in front of you and apply solving these problems. Okay, let's start by these questions. Here you can see this is square root of these numbers, and square root, the order of this sort is what? 2. Okay, now you see the law of fractional indices. Here when the order of the sort is n, then this can be expressed as a to the power 1 by n in fraction, which has the numerator 1, and by taking the order as denominators, these laws of fractional we can use here. Okay, similarly here also it has a order 2, so you can write them as a power of 1 by 2 by applying this formula. And we know this 1 by 2 is what? Power of this whole term. So 1 by 2 is power of this, now this 7225 also. This is power of x to the power minus 4 also. This is power of y to the 4 also. Okay, so we give the power to each term inside, each number inside. Okay, and so what we have done here, minus 4, they are power. Okay, so power and power multiplied. There is a law of power raising to power. That means if we have a to the power m and again it has a power n, then their powers are multiplied. Okay, so here this law is used here. Now 7225, this is the power of 85. Okay, you can use calculators to get this one. So this is power of 85 and 1 by 2 we already have. Similarly 2 ones are 2, when they are multiplied then we can cancel is 2 ones are 2 and minus 2 and 2 2. So we have x to the power minus 2 and y to the power 2. So this is cancels, so we have 85, and here the power of x is minus 2. So here we have to apply law of negative indices. So look at the formula and see what happened to the negative indices. It becomes positive in the denominator. So this is by the law of negative indices. So here also you will get here 1 by x square and y square. So numerator we can write here 85 y square and x square. Okay, this way using these different laws you have to solve it and simplify it. Okay, so you can see how important these laws of indices for you to solve this one. So I again suggest you to master those laws of indices. Here let's see another questions. X to the power b square plus 2ca multiply x to the power c square plus 2ab x to the power a square plus 2bc. Base, okay, base are same, and we know when the base are same, to multiply you have to use the law of multiplying the indices. According to that law, you see, if am and an, then by the law of multiplying indices the power are added. Okay, so by using this law, you know, x and the power are added here. 1 2, there are 3 power, so x to the power, their power, they are added respectively. Okay, so now we have to simplify in power here in indices. That means base remains same, then a square plus 2ab plus b square. Okay, a square written first and 2ab second, b square. So these terms in the power, they are arranged here because we know a square plus 2ab plus b square is what formula. So this returns, and 2ac and 2bc and c square, so they are arranged this way. After that, in place of a square plus 2ab plus b square, we can write a plus b whole square. Yes, this is formula. And here's, you know, look at here, in these two terms, 2 and c is common. Okay, if 2 and c is taken common, then what is left here? A left in the first and b left in the second, and they are arranged to a plus b c. Okay, so in place of these two terms, we can write here this one and plus c square. So again, you observe here, this is a square, 2ab and plus b square. Now these indices are also in the a plus b whole square, where a is a plus b and where b is c. So a plus b whole square we can write for the indices, for the power. So this is the simplification form of this one. Here we have one questions which is very important from the examination point of view, and which is interesting also. Okay, so how it is simplified? At first, 1 minus x a to the power minus b, and let's multiply numerator and denominator by x to the power b and x to the power b here. Okay, plus 1 by 1 minus x b minus a, and here let's multiply x to the power a and x to the power a. So one term they can easily multiply. Yes, and here two terms you have to multiply by this one term. So xb 1 multiply xb. Now here x a minus b multiply xb. So same way this also, x a by xa and xb minus a multiply xa. Okay, and xb numerator same is, and here xb, look at here, x base are same, and we can apply here the law of multiplying indices. So according to the law of multiplying indices, their power will be added. Okay, same here, xa x to the power a, and here xb minus a plus a. Okay, so xb we have here xb minus, look at here, minus b and plus b, they are cancels, so xa we have, and plus here also xa minus plus will be cancels, xb. xa, look at here the denominators, they are almost same. Okay, if they are same, then the calculation will be easier, so we try to make it same. Okay, it can be made same by taking minus common. If you take minus common, it become xb minus xa. Okay, to make the calculations easier, we try to make it same. And now xb by xb minus xa minus plus minus, here xa by xb minus xa. Now look at this, the denominator has been the same, so xa now in numerator xb minus xa. Okay, this way the calculation become easy by making the denominator same. So by taking minus, we have here make the denominator same. Now this cancels, then this is 1. Okay, this way we get 1, simplifying these terms. And here you have to remember why we choose to multiply by xb in numerator and denominators. Look at here x minus a, x to the power a minus b, here minus b is here, minus is b here. Okay, so if we multiply by xb, then that b will be cancelled. Okay, so these things you have to remember here. This is the trick for solving this, for simplifying these expressions. Okay, similarly here b minus a, so negative power is a, so we multiply numerator and denominators by xa, so that they will be cancels. Okay, this is the trick for the simplifying this one, and others you can do easily.